Hello students, I'm going to answer this question for the normal distribution. Sale amounts during lunch hour at a local Subway are normally distributed with a mean of $8.79 and a standard deviation of $2.29. Find the probability that a randomly selected sale was at least 6.63 or $6.63. So as soon as I see normally distributed, I usually draw the normal distribution with the mean and the standard deviation on it. So here is the normal distribution. The mean is 8.79 and the standard deviation is 2.29. Then I try to draw the area in the question. It says here, find the probability that a randomly selected sale was at least $6.63. So $6.63 is approximately here. And then at least means it could be this number or more than that number. So I'm going to highlight the area under the curve that represents at least. At least means 6.63 or more. Here are all of the numbers above 6.63. So it's the area to the right of 6.63. And I know that my function does not compute the area to the right of a number. It only computes the area to the left of the number. So to find the area to the right, you're going to use this function. 1 minus, that is the whole thing, minus the area to the left, which is blue here. So if I take the whole thing and cut off the blue area, I'm going to end up with the area shaded in red, which is exactly my answer. So 1 minus norm dot distribution of 6.63, comma, the mean, comma, the standard deviation, comma, true. It's always cumulative function because this is a distribution that is continuous. So we're going to go with the cumulation, and that is true right here for the normal distribution always. This function right here computes the area to the left of 6.63. So basically, this part of the formula is what computes the blue area. So if we take 1 minus the blue area, we're going to get the area to the right of 6.63, which represents at least 6.63. So I'm going to do that right here. 1 minus norm dot distribution, this is the normal distribution function, 6.63 comma the mean, 8.79 comma 2.29 the standard deviation, comma true, cumulative. That is how you're going to compute the first part. The second one. The second question says a particular sale was 12.59. What is the percentile rank for this sale amount? From the definition of percentile, we know that the area to the left of a number represents the percentile for that number. For example, the first quartile or the 25th percentile is basically separating the bottom 25% from the top 75%. So we name the percentile based on the area below it, not the area above it. To draw that, we're going to say, here is the normal distribution. I know the mean and the standard deviation, so I'm not going to write them again. 12.58 is approximately here. And percentile means the area under it. So I need the area to the left of it. And that's exactly what our function norm dot distribution computes. So if you have a number, you have the mean and the standard deviation, you'll be able to compute the area to the left of any number using the norm distribution function. So the area to the left of any number is equal to norm dot distribution of 12.58 comma the mean, 8.79 comma the standard deviation, 2.29 comma true. So I'm going to compute that here. Norm dot distribution of 12.58 comma the mean, 8.79 comma the standard deviation, 2.29 comma true. And that is going to answer my second question. Remember that we have to report this answer as a percentage, rounded to the decimals. I'm going to click on the number, go to home, and then make it into a percentage and then add 2 decimals to it using the functions that I showed you before, and that will be the answer. So we answered the first part and the second part of this question. Give the sale amount that is the cutoff for the highest 23%. So the first time we see this question, we're given the area and we need the cutoff. Here is the distribution again. I know the mean and I know the standard deviation, and excuse my sloppy writing or drawing. So the top 23% is this area right here, because we know that the area under the curve is percentages, it is probability, it is percentile, it could be proportion as well. And we need this number right here. Let's say we need A. If you're given the area and you need A, you can use the inverse function under one condition. The missing number is equal to norm dot inverse of the area to the left of that missing number, comma, the mean, comma, the standard deviation. And we don't have the area to the left of the missing number A in this case. So we need to find it. We can find it because we know the area under the entire curve is 100%, or it is 1. And if we subtract the area to the right, which is 23% or 0.23, you're going to end up with the area to the left. Let me compute it right here. 1 minus 0.23 is equal to 0.77. So the area to the left of the missing number A is 0.77. So I'm going to use norm dot inverse 0.77, the area to the left, comma, which the function here says the probability. The mean is 8.79. The standard deviation is 2.29, and it is mentioned in the question. So that is my answer, 10.48. Let's go to the next part. What is the probability that a randomly selected sale is between 5 and 10? So in this case, we need to find the area between 5 and 10. Here is 5 and here is 10. The area in between is basically norm distribution of the bigger number. So we can find the area to the left of 10, which is, I'm going to highlight blue. And if we subtract the little tail that I'm going to highlight orange in a minute, we're going to end up with the area in between 5 and 10. So here, if I take the blue area, which is, by the way, is equal to norm dot distribution of 10, comma, the mean 8.79, comma, 2.29, the standard deviation, comma, true, minus the orange area, which is the area to the left of 5, which is, by the way, norm dot distribution of 5, comma, the mean 8.79, comma, the standard deviation, comma, true. Then I'm going to get the area in the middle. So the area in the middle is always using these two. This is the big number and this is the small number. So norm dot distribution of 10, comma, the mean, comma, the standard deviation, comma, true, close the parentheses, minus norm distribution of 5, comma, the mean, comma, the standard deviation, comma, true. That is going to give me the area in between those two numbers, 5 and 10. Let's go to the last part of the question. What sale amount represents the cutoff for the middle 67% of sales? So I have the middle area between A and B as 67% or 0.67. Now I know that I can find A and B using the inverse function as long as I know the area to the left of each of these missing numbers, but I don't have that. I need to work a little bit to get it. I have the orange area, which is 67%, and I know it's exactly in the middle. I know the area under the curve is equal to 1, so if I say 1 minus 0.67, which is 0.33, I'm going to get the area in both of these tails together. So the area here is 0.33 in both of these tails. That's the remaining area basically. Now, I don't want the area in both of these tails together. I want the area in each of these tails. And I know that this area is exactly in the middle. The shape is symmetrical about the mean. That means I can divide this amount into 2 and I will get the area in each tail. So 0.33 divided by 2 will give me 0.165, I think. So here, 0.33 divided by 2, and I got the area in the tail. So the area in this tail is 0.165. I don't care about the other one. Now, I have the area to the left of A, which is, I'm going to highlight yellow. That is the area. So I can find A using the inverse function. A is equal to norm dot inverse of the area or the probability, comma, the mean 8.79, comma, the standard deviation 2.29. So that is how I'm going to compute A. So norm inverse of 0.165, which is the function calls it the probability. The mean is 8.79. The standard deviation is 2.29. Similarly, I can find B. I need the area to the left of B, which is combining the yellow area and the orange area together. So if you add the orange area, 67, plus the yellow area, 0.165, then you're going to get the area to the left of B, and B will be equal to norm dot inverse of 0.835, comma, the mean, comma, the standard deviation. So I'm going to do it here, norm dot inverse of this number right here, which represents both of the areas combined, or the area to the left of B, comma, the mean, 8.79, comma, the standard deviation. It helps if I typed here the mean and the standard deviation and I clicked on them each time. Typing takes some time, so be efficient. Sometimes that helps. I hope this video helped you understand the concept of normal distribution and the normal inverse function, and I will see you in a different video.